Hello, welcome to Mystery Science. This video is going to be about circular motion, moving around in circles. It's part of the CP2 section of the Edexcel GCSE course. It's lesson 3, but it kind of fits into lesson 2. The reason I've separated it, and the reason it's separated in many schools, is that this is part of the higher tier topic only. If you know, so if you're in year 11 revising for your exams and you know that you've been entered for the foundation tier, you can skip this video. However, if you don't know for a fact that you're on foundation tier, I would suggest you learn the higher tier stuff anyway, and then you can go back downwards anyway. It's not going to harm you knowing some extra bits and pieces. What I'd like you to do is think for a moment, if an object is moving around in a circle at a steady speed, is its velocity changing? And if you've already watched the last video that I made, you may, or hopefully should know the answer. Just pause the video, write that down. Okay, so the key to that do now question is the fact that velocity is a vector. It changes direction, therefore the vector is changing because the vector is always changing. So the direction is changing, the vector is changing, therefore velocity is changing. The speed could stay the same all the way around, but because the direction changes, there is always a velocity. Okay? So when they're moving in a circle, there is always a change in velocity. So if the velocity is always changing, is the object accelerating? Write down the answer, and I want an explanation for your answer as well. Okay, so if the velocity is constantly changing, is there an acceleration, and why? And the answer is yes. If you have a change in velocity, you must have a change in acceleration, because the definition of acceleration is the change in velocity divided by time. Now, if you use the equation for working out acceleration, you'll notice that the magnitude of the velocity, which is in fact the speed, doesn't change. So your acceleration does come out numerically as 0, but because there's a constant change in direction, therefore there is an acceleration. Okay, so let's look back at Newton's first law. Newton's first law says the motion of an object will remain unchanged unless acted upon by a resultant force. So I take this pen and just hold it here. This is Newton's first law. An object at rest is staying at rest unless acted upon by a resultant force. So here is my question to you, and this involves thinking. What do you think must be present for an object to move in a circle? Pause the video, give yourself some time, think about this. What must be present for an object to move in a circle? All right, welcome back. What did you think was present for an object to move in a circle? Well, if an object's velocity is changing and there's an acceleration, there must be a resultant force present, because an acceleration or a change in velocity is a change in motion. Newton's first law says the motion cannot change unless there's a resultant force. If there's a resultant force, you have a change in motion, like a change in velocity or an acceleration. So if an object is moving in a circle, there must be a resultant force present. Okay, so we have a resultant force, but this force is called the centripetal force or centripetal force, depending on who you ask. Now, what I want you to do is think about this. What direction must the centripetal force or the centripetal force be acting? We have a constant change in motion because we have a change of direction. So there is a force acting, but where is it acting? What direction is it acting in? And it's in a circular motion. It's always the same answer. Pause the video, have a deep think, write down your answer, and come back to me. All right, welcome back. Now then, if you notice that when my pen moves around, if I get it into the camera, when the pen moves around, it is constantly changing direction. It's constantly turning this way. Okay, so if it's down here, it is turning this way. If it's down here, it's turning this way. If it's up here, it's turning this way. You'll notice that it's always turning towards the center of the circle, and that's the direction the force is acting. The force is acting towards the center of the circle, the direction which the object is changing to. Sorry, I've overwritten the text there with my face, but you know, my face is much more important than the text. Just know that the force acts towards the center of the circle, and that's the direction which the object is traveling in. So it keeps changing towards the center. Okay, so the centripetal force on this fairground ride is provided through the tension in the wires holding the seat. So the tension is moving towards the center of the circle up towards the top of the fairground ride. That spins around, the chairs then swing outwards. But Mr. E, if I sit on one of these chairs, I feel a force pushing me outwards and down and away from the roof of the carousel. What's that about? You told me it acts towards the center. Well, it does. And the feeling that you have is actually your velocity being changed. The force is pulling you towards the ceiling of the carousel, but you're constantly changing velocity. And that constant change of velocity you are feeling because you are having a reactionary force with the chair. So this centrifugal force, as people call it, is actually a fictional force. It doesn't exist. There is no force pushing you downwards, but it feels like there is. There are other fairground rides where you sit or stand right on the edge and it's sloped like this and it spins round with you inside it. And when it reaches a certain speed, the thing that you're standing against will actually lift. And you are basically pinned to the wall of the fairground ride, and it just spins round and round. And again, it feels like the force is pushing you into the wall, but it isn't. The force is actually pulling you towards the center of the fairground ride. But because your velocity is changing, it feels like you're being pushed this way, and that's actually the reactionary force of your body pushing against the thing that's pushing you, that force. And we'll talk more about this when we go into Newton's third law. But it's important to know that centrifugal force doesn't really exist, but most people refute that because that's what they think they feel. In this example, this motorcyclist is going around a bend. And so he's going to be exhibiting circular motion, or part of a circle. And what's causing that to happen? Well, the friction between the floor and his tyres, that's causing the centripetal force. That's changing his direction. Right, last thing I'd like you to do, write down one key thing you've learnt today, and then what I'd like you to do is write down one thing you wish I had explained better. If you're from my college and you're doing this as part of the lockdown work, please submit that in the normal way. If you are a YouTube viewer and you want to participate, then you can feel free, please, to put that in the comment. Good feedback is always welcome. If you found value in this video, please tickle that like button, give it a little boop, then it turns blue and everything is good. Right, stay safe. I'll see you soon.